Hello and welcome to this TTA TV video. The key concept associated with orthographic projection is that parallel lines appear parallel in every orthographic view. Now we'll take a look at how orthographic projection is applied in the real world. So for instance, if you are a carpenter or builder or anybody that makes something, very often you will use the plans of a piece of furniture to construct it. And this will involve accurate, two-dimensional projection views which show the front, side and top view of an object, such as the chair which is seen on screen. Also in construction, orthographic projection is used to produce working drawings which detail the various views of a building and which maintain the relationship between height, depth and width so that the building can be accurately constructed from these drawings. So that's where orthographic projection is used in terms of applying it in the real world. Now we're going to look at how we draw orthographic views using our drawing equipment. So if you take this sample object where the sides and different surfaces are color coded, we're going to look at how we would draw the views depending on where we are standing. The first thing to do with an orthographic drawing is to set up your XY line. And of course, as we've seen before, the XY line represents the intersection between the horizontal plane and the vertical plane. So we do this on our drawing sheet, like so. The next stage of the process is to start by projecting one of your views of the object onto a plane. In this case, we're going to start with the front of the object and we're going to project it onto the vertical plane. So we'll be standing where we see the green man, and as he looks at the objects, the colour-coded surfaces which are in green will be what is seen. So if we were to project these onto a vertical plane behind the object, we begin to see what the orthographic view looks like. Now in the drawing you will see heights being marked off and widths being marked off. And as these come together, you begin to see the angle at the front, the perpendicular back, horizontal line across the top, and then finally we have the detail to put in of the side piece and the top piece. An important note here is a principle we mentioned earlier on, that parallel lines remain parallel in orthographic views. So they don't vanish off like perspective does, they remain parallel. And this allows somebody that perhaps been making this object to understand that concept. So now that we have our first view drawn, we'll take a look at another orthographic view. In this case, we're going to look in from the side of the object and also project it onto another vertical plane. So now we're taking the view of the blue person, looking in perpendicular to the side of the object and projecting the lines onto the plane behind the object. This is often known as an end view in terms of what view it is in the orthographic drawing. Now when we're drawing this, we can translate the heights over from the elevation, and you'll see that in the video. Because heights remain constant, we can just translate them over and don't have to measure them again. So this is a quicker view to draw because all we really have to mark off are the widths of the object. And you'll see it coming together now in terms of the different features and different parts. The final view to complete for this particular drawing is a plan view. And here we are taking a bird's eye view and we are projecting downwards onto the horizontal plane. So on our drawing sheet, we again can save time by dropping down the length of the object from the elevation. Another handy tip is to take our end view and to take the widths that we have already marked off and to translate them down to our plan view. So there are various different ways of doing this. Some people will use a compass to swing the widths around, and other people will use a 45-degree set square. In the video on screen, you'll see the 45-degree method being demonstrated. So the plan view can now be obtained by cross-referencing the lengths of the object from the elevation, which will drop straight down, and the widths of the object, which are brought down from the end view. And again, this just saves time in terms of having to individually measure everything. We have our measurements on the drawing sheet already, and we can utilize that So now we get a picture of what the object looks like in its elevation, its end view, and its plan view. So if we were to hand this to somebody, they would be able to construct that object or make the object from whatever material they choose based off this accurate orthographic projection of it. That's all for this video. And as always, we'd like you to subscribe to the TTA TV channel for more videos like this. Thank you for watching.